Okay, we're going to talk now about direct variation with a power of x. Here's the definition. We say that y varies directly with a power of x if y is equal to a function of x with this definition, k times x to the n, where k and n are both positive numbers. So you could, having all three of these written here means you could just think of it as y equals kx to the n, or just f of x equals kx to the n. They mean basically the same thing, because generally y and f of x mean the same thing. So some examples of that are if you have an equation that can be written as y equals 3 times x to the fourth power, that is a that means y varies directly with the fourth power of x. Or if you can write a relationship as, I don't know, f of p equals, I don't know, 1/3 times p squared, that's direct variation with a power too. So if you can get an equation that looks something like that, where both of the constant of variation in front and also the exponent are positive numbers, then it's direct variation with a power. So let's look at this example here. We want to check that the area of a circle, which we're calling A here, varies directly with the square of the radius. Now this is actually the same example we did in the first video of this section, where we found out that if you just do A divided by R to see if A and R are directly proportional, you get different ratios at every point here. So A and R are not proportional, but maybe A and R squared are proportional. So in other words, if A is proportional to R squared, there'd be a number k so that A equals kr squared. And we know that this is equivalent to, if you just divide both sides by R squared, saying A over R squared equals k. And that always needs to come out the same way. So that's what we're going to test, is does this work? So let's start with the 3.14 and the 1. If we do 3.14 over 1 squared, you get 3.14. Let's just test it with the other ones with a calculator. So again, what I want to see is if I do A divided by R squared, is it always going to come out to the same thing, which was 3.14 there? And if you do 12.57 divided by 2 squared, you get about 3.14, yeah? If we do 50.27 divided by 4 squared, get about 3.14. If we do 201.06 divided by 8 squared, we get about 3.14. So I'm going to go ahead and say those all came out slightly off because we probably rounded off these areas in the first place. They're all good to at least 2 decimals. So because the rest of them worked too, we're going to say that yes, it does vary, and the k that you get is pi. So for part B, find a function for the area in terms of the radius. We know that a over r squared is always equal to pi. We just tested that with all of them. And of course, you could just write that as a equals pi r squared. And that is fine. If you really want to write it with function notation, you could also just say a is a function of r, and the formula for that function is pi times r squared. So that is that. And by the way, if you already knew the answer to this at the beginning because you know that area is equal to pi r squared, good for you, but this is a method you'll have to use even when you don't already know the answer. But so it's good to learn this method as well. So next, here's an exercise for you to do, it's given that the volume of a sphere varies directly with the cube of the radius. So the cube of the radius, just to give you a head start here, that means r cubed to the power 3. So it's saying it's giving you that the volume is equal to some number k times r to the power 3, and you've got to find that number k. So good luck with that, and I'll talk to you in the next video.